Nice question here. We've got a transformation A represented by this matrix in terms of x, and then a tetrahedron, H, is being transformed using it. The volume of H is 6. We're then asked in the case where x is 5 to find the volume of H dash and to determine whether the transformation preserves the orientation. So we're going to need to look at the determinant of A to find the volume scale factor. When x is equal to 5, this matrix A is then going to become -1, 5, 2, 7 minus 5, and minus 6, 1, 5, minus 25, and 10. Now, one approach to this question is just to put this in your calculator. Absolutely fine to do that. You have to find the matrix. There we go. Define our matrix. 3 rows, 3 columns. I'm not doing it particularly fast because I'm doing it on my computer, but yeah, you can do it a lot quicker than me. Okay, there we go. Then go to matrix calculation. Option again. We want to find the determinant. Back to matrix A. And we get -80. So this means the volume of H dash, the volume scale factor is going to be 80. I just do 80 times 6. It's going to be 480 units. Determine whether it preserves the orientation. The answer is going to be no. Determinant, because it's less than 0, that necessarily means it changes the orientation. It's like when you have a rotation, you actually change the orientation, but if you do, I'm working in 2D now, but if you do a reflection in, say, let's say in the y-axis, then it's actually changing the orientation. The determinant would be less than 0. That's what it always means. So that's A less than 0. So A does not preserve the orientation. Okay, I would show how to do the determinant by hand, but we're actually going to have to do it in part B, so I'm going to skip it. But of course, you could do it by hand rather than using a calculator. In part B, we're asked to find the values of x for which these transformed points are coplanar. So the 4 points now lie in the same plane. What that actually means is whilst we had a tetrahedron to begin with, which is I don't know, which is like a triangular pyramid essentially. So this is now somehow being transformed to maybe just something that's flat. Who knows exactly what it's going to look like, something like that. But the key thing is that it's not going to have any volume. So um, new structure, I don't know what else to call it, has V equals 0. And remember that the determinant was the scale factor. It follows that it must be the determinant of A is equal to 0. So now we've got to find that from the original matrix. No, we don't have 5 anymore. This is a general thing. We're going to solve for x. So let's work it out. I'm going to expand, I think, along the first row. That's always just a good shout unless there's advantages. So -1 times the determinant when you cross out the row and the column. So -6, 1, -5x, 2x. Then minus, it's going to be a plus here, a minus here, and a plus here, because it's the -1, the power of the row plus the column that you then have to times by as you find out the determinant. So minus x times the determinant, cross this out, and you get 7 minus x, 1, 5, and 2x. and then back to it being plus 2, 7 minus x minus 6, 5 minus 5x. This gives minus 12x minus 5x, that's plus 5x, minus x times 7 minus x times 2x minus 5 plus 2, 7 minus x times minus 5x, then minus 30, so that's plus 30. Okay, remember this is all equal to 0, but I'm just continuing to simplify it. I'm going to get minus 7x, but then minus of that, so I'll get 7x minus x times 14x minus 2x squared minus 5 plus 2 times minus 35x plus 5x squared plus 30. Okay, it's getting simpler every time, just be careful. So, got my 2x squared, sorry, 2x cubed, sorry. Then minus 14x squared plus 10x squared, that's minus 4x squared. Then minus 70x plus 7x, that'll be let me add the 12. So I've got 12x minus 70x, that's going to be minus 58x, and then plus 60 is equal to 0. Okay, and finally set it equal to 0 after all that calculation. What you could do here is divide through by 2, and then use the factor theorem to try and find factors. When you put 1 in fact, you will get 0. So x minus 1 would be a factor. You can do a polynomial division, but we don't have to. It doesn't say we have to show detailed reasoning. It is okay to, again, use our calculator and just solve the cubic. So equation function, polynomial, degree 3, 2, minus 4, 58 and 60s. Kind of have to think about how long they would expect you to spend getting just 4 marks. We've had to do this. We can't do it that bit any quicker. So this bit here is just like an extra mark at the end, really. This is just, we know how to solve a cubic. And so it gives minus 5, 6, or 1. All of those values would lead to the points becoming coplanar. Okay, I like that question. I feel a little bit, I kind of want to do the polynomial division, to be honest, after all of that. I don't want to just rely on my calculator at the end, but we do have to think about, the number of marks and how long you should spend on each bit. So, by all means, try it out, practice that. And do you know what? it just feels unfinished without doing it. So what I would do is divide through by 2. And then call this thing, say, f of x. Put in 1. It's always a good one to start with. 1 minus 29. Oh, sorry, minus 2. I swapped them around accidentally. That's going to give me 0. By factor theorem, x minus 1 is a factor. Polynomial division is a good shout. Okay, x cubed divided by x is x squared, times back through. Subtract gives me minus x squared minus x here, which gives me minus 30x. Yeah, minus 30 gives me 0, so we're done there. Therefore, x minus 1 times, and I can factorize this, x minus 6, x plus 5, that's quite quick, equals 0, and we're going to get the solutions. Of course, make sure you can do this, Right, glad I did that. Well done on this question.